Okay, last Calculus 1 video. Find the area of the region enclosed by the curves x equal, and we've got to zoom in on that so you can see it a little better, x equal 9 over y and x equal 10y minus y squared, which happens to be y times 10 minus y. And I think I just took this out of a book, and maybe that's the way they wrote it in a book. Okay, didn't give you a graph. Now I will set your mind at ease somewhat that when you're given functions in terms of y, especially if they get a little bit complicated like that, I will provide the graph for you, because this is not something you can do easily on your calculator. So if this were the sort of problem, I would provide it for you on a testing situation. In your homework, it depends on the homework. Okay, so as I look at this, the functions are in terms of y. So it'll be best to integrate in terms of y and use horizontal rectangles. The reason why it's going to be best to use y is if I wanted to use x, I'd have to rewrite my functions in terms of x, which you could actually do in this case, but it's kind of messy for this guy. It's doable here. You could use the quadratic formula and rewrite that in terms of x, but it's a little bit messy. But that process in general of switching functions around from one variable to another can be actually relatively, it cannot be necessarily possible to do with elementary means, and sometimes it gets to be things that you don't want to do. And so it is easiest to usually go with the variable that you were given. Here we are given things in terms of y, so we're going to go with y. Now we still need a picture. Go out a little bit. So to graph, ... for the x equal 9y. Now, I just said don't rewrite things, but this guy is very easy to rewrite. And this will have the same graph as y equal 9 over x to solve for y. So that'll be easy to graph. Then to graph this one for the other guy, for x equal 10y minus y squared. Some things just to note in general. The y squared makes it a sideways parabola. And the negative y squared means it opens left. Other than that, unless you had a really good algebra teacher, some really good algebra teachers, and they really pounded into you, some really good algebra teachers maybe spent the time graphing sideways parabolas. I know when I teach college algebra on this campus, I never spend the time doing that. So since I haven't spent the time, I'm going to go with the t-chart, just your old-fashioned t-chart, x and y, where I'm going to pick y, calculate x. Pick y, calculate x. So I did this before I came to class, so I didn't look like a fool on the video, or if there are people in the room, so I wouldn't look foolish. I picked 0, 2, 4, 6, 8. Pretty much the 0 to 0, 2, 4, 6, 8. Pretty much 10. Going from the 0 to 10, can I get it all on one piece of paper? One shot here. Going from 0 to 10, because of the way I put it up here, that those are going to be my y-intercepts. That if I let, or my, if I let y equal 0, I get a 0 there, and if I let y equal 10, I'm going to get a 0 there. So that's why I went from 0 to 10. That I decided that those were kind of going to be the important numbers. But now, picking y, calculating x, and you're just going to trust me on this. You're going to get 0, 16, 24, 24, 16, and 0, which is going to give me a graph that looks something like this. And you don't need tremendous works of art. You just need a nice little general thing. And so I have, and let's do the parabola in red. So I have the point 0, 0. And then I also have the point 0, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I have the point 0, 0, 0, 10. Move that up a little bit. And then just roughly graphing the other things. 2, 4, 6, 8. 2, 4, 6, 8. No, that's not the way I'm supposed to. Those are my y coordinates. Never mind. These are my x coordinates. So let's change this. I wasn't paying enough attention. This is my x-axis. Let's call this, what we've got, 16, 24. What if we go 4, 8, 12, 16, 20, 24. I've got 16, 2, which would be right about there. Red. I've got 24, 6, 24, 4, 1, 2, 3, 4, which would be right about there. I've got 24, 6, 1, 2, 3, 4, 5, 6, which would be right about there. And I've got 16, 8, which would be right about there. And so it looks something like that. Pretend that looks like a nice smooth parabola. It doesn't. I'll try to do a little bit better. There, that looks a little better. So there's that guy, and that is way sufficient there. And so there's x equal, and it was 10y minus y squared. And again, emphasis, if this were on a test, I would give you the graph. Then you can ask your calculator what, so the other one I had, I'm going to get rid of my t-chart there for a moment, or cover up part of my t-chart, y over 9x, and you can just ask your calculator what that looks like. And that looks something, I shouldn't have done it in blue, but I already did it in blue, so we'll go with it. It's going to look something like that. It's that hyperbola in there. And so there's the x equals 9 over y. And so what I've got there is a very consistent left and right. And I'm sorry the picture's a little messy, but not an artist. But now that I have my picture, the last thing I need to know, and this is off, my picture's a little bit off, but that's okay. The last thing I need to know here are these points. I need to know that guy, which we'll call C, and that guy, which we'll call D, that those are my points of intersection. So CD points of intersection of the x equal 9 over y and x equal 10y minus y squared. Set those guys equal to each other and solve. Clear the fraction. Multiply everybody by y. And so I get 9 equals 10y squared minus y cubed. Set that equal to 0. It's a polynomial function, set it equal to 0. Now here's something I absolutely will not do to you. This was just a nice little example that I wanted to do. This guy actually does factor. I don't expect you to remember how to factor it, so you're just going to trust me that it factors to y minus 1, y squared minus 9, y minus 9. Now it's factored and equal to 0. And again, I wouldn't do that to you on a test or quiz, and I don't believe it creeps up in homework. I hope not. But that does factor. And again, if you had a really good algebra teacher, you might remember how to factor it. But it's now factored and equal to 0, so I can split it up. And so I get y minus 1 equals 0. And y squared minus 9y minus 9 equals 0. So I get y equals 1, and then this guy, and I'm not going to show all the steps, but using the quadratic formula, you get x equal 9 plus the square root of 117 over 2, and 9 minus the square root of 117 over 2. This guy is negative. Because there's another branch of the parabola over here, and so it's picking up this guy over here. So this one's negative. And this approximately equals 9.9. Now, like I said, not allowed to guess from your graph, and here's a perfect example of why you're not allowed to guess from my graph. My graph is not terribly accurate here, but it is not so far off that I wouldn't believe these values. So I get y equals 1. That's not at y equals 1, but thinking that it might be at 1 given that I'm a horrible artist, not an impossibility to believe that that's y equals 1. And the same thing over here, this guy, which is about 9.9. Again, this looks closer to 10. Looks like maybe even a little bit bigger than 10, but it seems reasonable. And so there are my points of intersection. So all I have to do now is set up the integral. So the area is going to be my lowest point of intersection, 1, to my highest point of intersection, and we will be perfect mathematicians and say 9 plus the square root of 117 over 2, and then right minus left. The right side of the curve is 10y minus y squared. The left side of the curve is 9 minus y, right minus left. And now we integrate. So increase the exponent by 1, multiply by the reciprocal of the new exponent. Increase the exponent by 1, multiply by the reciprocal of the new exponent. And please note there that that's 9 times 1 over y. So that 9 is just a coefficient, and then the antiderivative of 1 over y would be the natural log of y, evaluated from 1 to 9 plus square root of 117 over 2, and now it's arithmetic, and boy God, I am not interested in doing that arithmetic, so I'm not going to do that arithmetic. But the point to this problem is because we were in terms of y, we integrated using y. And when I use y, I've got to go right minus left. Set the whole thing up, right minus left, using my lowest y coordinate to my highest y coordinate, and that gives me the integral. And that's the end of the area section, and that is the end of calculus lectures in Calculus 1. Finals will be coming soon. Good luck.